Bismillahirrahmanirrahim. Assalamu alaikum. The topic of my presentation is response of wheat varieties to foliar application of selenium and salicylic acid under salt stress. Salt stress is a major abiotic stress that extremely limits wheat growth and productivity globally, producing over 780 million metric tons globally. Wheat play important role in ensuring food security for developed and developing nations. The use of plant growth regulator and micronutrients such as selenium and salicylic acid has emerged as an effective strategy to enhance stress tolerance. Despite the well-documented individual benefits of selenium and salicylic acid in improving wheat performance under salt stress, research examining their combined foliar application is limited. Therefore, the peasant study was designed to evaluate the individual and combined effects of foliar applied selenium and salicylic acid on the growth, physiological traits, and biochemical attributes of wheat grown under varying levels of salt stress. Objectives of this study were to assess the impact of NaCl-induced salt stress on morphological, physiological, and biochemical parameters of wheat, determine the effect of foliar selenium application on antioxidant enzyme activity, osmotic adjustment, and yield components under salt stress, to evaluate the role of selenium and salicylic acid in modulating oxidative stress responses, oxidative stress responses and photosynthetic efficiency in salt-stressed wheat, and examine the interactive effects of combined selenium and salicylic acid foliar application on the overall growth and productivity of wheat under salt conditions. Research methodology. A pot experiment was conducted to explore the effect of foliar application of selenium and salicylic acid on two wheat varieties, Dilkash 20 and MH21 under salt stress. Seeds of two wheat varieties were collected from Ayub Agricultural Research Institute, Faisalabad. 4 levels of foliar application, that is non-spray, 1 millimolar selenium, salicylic acid 1 millimolar, and combination of selenium and salicylic acid were used. 2 levels of salt stress, that is 0 and 100 millimolar NaCl in full strength Hogland's nutrient solution were used. Salt stress was applied after 3 weeks of germination. Foliar application was performed after 3 weeks of salt stress application. The experiment was performed in a completely randomized design with 4 replicates. Results of current study show that different growth attributes like plant height, fresh and dry biomasses significantly decreased in both wheat varieties under salt stress of various treatments, that is selenium, salicylic acid, and the combined selenium and salicylic acid. All treatments increased the shoot plant height and fresh and dry biomass. However, the combined selenium and salicylic acid has profound effect in increasing the plant height and fresh and dry biomass of both wheat varieties. However, Dilkash 20 showed more positive response towards combined application of selenium and salicylic acid as compared to MH21. Chlorophyll contents, chlorophyll A and chlorophyll B, decreased under salt stress. However, the selenium and salicylic acid in combination increased the chlorophyll A synthesis in both wheat varieties. However, Dilkash 20 showed more pronounced effect as compared to MH21. And in total chlorophyll contents, Dilkash 20 showed more profound response towards the combined application of selenium and salicylic acid as compared to MH21. In other pigments like carotenoids, carotenoids also decreased under salt stress. However, the combined selenium and salicylic acid maintains the carotenoid levels in both wheat varieties. Yield parameters. The different yield components like spike length, grains per spike, 1,000 grain weight, and biological yield and harvest index decreased under salt stress. However, the combined foliar application of selenium and salicylic acid improves the spike length, grain numbers, grain weight, and improves the biological yield and harvest index. And of the two wheat varieties, Dilkash 20 show more pronounced effect and for better performance than MH21 under the foliar application of selenium and salicylic acid under both stress and non-stress conditions. This is the graphical and statistical representations of the results that shows that shoot length, root length, grain yield per plant, and under grain weight decreased under salt stress. However, different foliar applications significantly enhanced the growth attributes in both wheat varieties. And of the two wheat varieties, Dilkash 20 was higher in grain yield per plant and shoot and root length. Oxidative stress markers like malondialdehyde and hydrogen peroxides increased under salt stress, while the foliar application of selenium and salicylic acid in combination decreased the malondialdehyde and hydrogen peroxide contents in both wheat varieties. And this is the graphical and statistical representations that shows the contents of photosynthetic pigments, chlorophyll A, chlorophyll B decreased under salt stress, while the different foliar applications uh, in singly and in combined form significantly enhanced the chlorophyll A and chlorophyll B contents in both wheat varieties. And the leaf malondialdehyde contents and total soluble proteins increased under salt stress in both wheat varieties, while Dilkash 20 show the that the contents of malondialdehyde were lower as compared to MH21. That shows that Dilkash 20 show less damages in membranes as compared to MH21. Total chlorophyll and carotenoid contents decreased under salt stress in both wheat varieties, while the combined selenium and salicylic acid significantly enhanced the total chlorophyll and carotenoid contents in both wheat varieties. Leaf relative membrane permeability and hydrogen peroxides increased in both wheat varieties under salt stress, and however, the foliar application of selenium and salicylic acid in combination decreased the leaf relative membrane permeability and hydrogen peroxide contents in both wheat varieties, and the response of Dilkash 20 was better as compared to MH21 towards the foliar application of selenium and salicylic acid under salt stress and non-stress conditions. The activity of different antioxidant enzymes like ascorbate peroxidase, superoxide dismutase catalase, and glutathione peroxidase increased under salt stress, while the foliar application of selenium and salicylic acid further enhanced the activity of ascorbate peroxidase and significantly boost the activity of peroxidase, catalase, and glutathione peroxidase. The graphical representation and statistical analysis shows that the activity of different antioxidant enzymes significantly increased under salt stress and under the different treatments of selenium and salicylic acids in both wheat varieties. Among other biochemical attributes, soluble proteins, amino acids, total phenolics, flavonoids decreased under salt stress. However, the foliar application of selenium and salicylic acid increased the protein contents, amino acids, and phenolic compounds in both wheat varieties. Statistical analysis shows that of various treatments, the combined application of selenium and salicylic acid significantly increased the total free amino acids and the total phenolic contents, total flavonoid contents, and the activity of superoxide dismutase in both wheat varieties under salt stress and non-stress conditions. Ionic balance Shoot and root sodium and potassium significantly increased under salt stress. However, the foliar applications of selenium and salicylic acid decreased the root and shoot sodium contents while increased the accumulation of potassium contents in root and shoot. Similarly, sodium to potassium ratio increased, that is under unfavorable conditions, while the application of selenium and salicylic acid restores ionic homeostasis, and the of the two wheat varieties, Dilkash 20 showed more pronounced effects and showed better performance than MH21 under salt stress and non-stress conditions. A byplot of wheat varieties under salt stress and non-stress conditions that shows that DIM1 is 68.1% shows variance, while the DIM2 shows 12.8% variance among different treatments that are shown in different colors and shapes here. Cluster analysis, that is heat map of wheat varieties under salt stress and non-stress conditions. Here, the map shows the clustering of two wheat varieties under stress and non-stress conditions and under different treatments of selenium, salicylic acid, and the combined application of selenium and salicylic acids. Here, the different colors like the light sky color and dark blue color show the true stress levels, while the treatment in among the three different treatments, the green color is control, golden color is selenium 1 millimolar, white is salicylic acid 1 millimolar, and off-white is selenium plus salicylic acids. And the two varieties that shows red color is of MH21, green color is Dilkash 20 under control condition, and dark blue is Dilkash 20. The map shows that the Dilkash 20 was higher in the potassium to sodium ratio, grain yield components, and the activity of antioxidant enzymes, and the accumulation of different osmoprotectants like total soluble proteins, phenolics, total free amino acids, and proline and glycine betaine contents under control and salt stress conditions. In conclusion, salt stress of 100 millimolar NaCl reduced growth attributes and chlorophyll contents while increased relative membrane permeability. However, combined selenium and salicylic acid application significantly increased growth, yield, activity of antioxidant enzymes like ascorbate peroxidase, superoxide dismutase, catalase, and other biochemical attributes including protein, amino acids, phenolics, and flavonoids. Salt stress increased sodium accumulation in root and shoot and oxidative stress markers like malone, D-aldehyde, hydrogen peroxide in leaf. Overall, selenium and salicylic acid enhanced salinity tolerance by improving physiological biochemical attributes, ionic regulation, and mitigation of membrane damages. Of two wheat varieties, Dilkash 20 performed better than that of MH21 under salt stress or non-stress conditions. Thank you.